Whether we watch Big Hero 6 or Avengers Age of Ultron, we have an understanding of what nanotechnology is. Science fiction loves to portray an evil image, but we promise you that in real life, it is being used for something way cooler and good. For this month's edition of Hidden Figures, we're going to be celebrating the pioneer of regenerative engineering, Dr. Cato T. Laurencin. Dr. Laurencin is an engineer, physician, scientist, innovator, and sometimes even a university professor. His story dates back to 1959 when he was born and raised in the inner city of North Philadelphia. He eventually moved to Princeton University to complete a bachelor's in mechanical engineering, scaling up to obtain an MD from Harvard Medical School and a PhD in biochemical engineering, biotechnology from MIT. Dr. Laurencin then started practicing sport medicine and shoulder surgery. His 15 years of work made him distinguishable as one of America's top doctors, along with distinctive fellow titles from the American Academy of Orthopedic Surgeons, American College of Surgeons, and the American Orthopedic Association. Cato's talents were so good that he was recognized with the Nicolas Andri Award, the highest honor of the Association of Bones and Joint Surgeons. However, his most significant impact was yet to come. Dr. Laurencin's research was getting involved with tissue engineering, biomedical science, nanotechnology, and stem cell science. But before we talk about that, let's take a look at scientific history. The regenerative engineering was first coined in 1987 by Y.C. Feng, who described it as an interdisciplinary field that applies the principles of engineering and life sciences toward the development of biological substitutes that restore, maintain, and improve functions or whole organ. Dr. Laurencin further defined it as the application of biological, chemical, and engineering principles toward the repair, restoration, or regeneration of living tissues using biomaterial, cells, and factors alone or in combination. Over the past 25 years, advances have been made in biomedical-based tissue engineering research to repair organ systems. 3 areas of technology emerged: nanotechnology, stem cell science, and blastema. Nanotechnology has been ushered as a tool for engineering tissues. Stem cell science has created a deeper understanding of both adult and embryonic stem cells, as well as characterized and used pluripotent stem cells. Lastly, the new sophisticated understanding of the developmental biology mechanisms in the salamander and the newt, in conjunction with the role of the blastema in regeneration, has furthered the efforts in wound repair and regeneration. Each of these scientific advances has matured to an extent of being regarded as tools rather than concepts and ideas. This is where the field of regenerative engineering was born. Essentially, it was the integration of tissue engineering with advanced material science, stem cell science, and areas of developmental biology. This field will harness and expand this newly developed tool toward the regeneration of complex tissue. Before, the tissue engineering was largely focused on the restoration and repair of individual tissues and organs. But with these new advancements, there is the possibility to start considering the regeneration of more, like biological systems. So, how does that connect back to Dr. Laurencin? Well, Dr. Laurencin is the founder of the regenerative engineering field. He produced seminal studies in a number of areas of engineering and science. In fact, he and his colleagues were the first to develop nanofiber technology for tissue regeneration, and his group pioneered the development and understanding of polymer ceramic systems for bone regeneration. This launched the use of nanotechnology in musculoskeletal regeneration and ushered in a new era of orthopedic therapy. Dr. Laurencin continued to work in the development of systems of soft tissue regeneration and invented the Laurencin-Cooper ligament, LC ligament for short, for the ACL restoration. To understand it a bit, the ACL injury, a torn ligament in the knee, contains a storehouse of nutrients and stem cells, which have the potential to grow into new tissues. Dr. Laurencin's method involved using those cells that were already present by placing a specially engineered matrix where the ligament should be. Cells attached to it, creating new cells. National Geographic named the LC ligament one of its 100 scientific discoveries that changed the world in 2012. For his work, the National Institute of Health, NIH, allocated him the Director's Pioneer Award for his transformative work in regenerative engineering. He was also honored by the White House on 3 occasions. He received the Presidential Faculty Fellow Award from President Bill Clinton for his work bridging engineering and medicine. He received the Presidential Award for Excellency in Engineering, Science, and Math Mentoring from President Barack Obama. More recently, he received the National Medal of Technology and Innovation from President Obama, which is the highest honor bestowed in America for technological achievements. Dr. Laurencin's resume could go on, and it's truly phenomenal. But he has also been active in mentoring underrepresented students and is an activist against health disparities. He even has 2 awards named in his honors: the Cato T. Laurencin Travel Fellowship Award, given by the Society of Biomaterials, and the Cato T. Laurencin Lifestyle Research Achievement Award by the W. Montague Cubb National Medical Association Health Institute. No doubt that Dr. Laurencin's work will leave a lasting impact on human health and the entire field of regeneration technologies, and we're more than sure that he will be a part of our history books in the future. Thank you all for watching, and if you like this, please like and subscribe.